Looking further down in the same section on the Arduino Uno product page, we can see here that it says that the Atmega 328 also supports I²C, which is also known as TWI, and SPI communications. Let's have a look at I²C first. And to do that, let's check out the Wikipedia article on this topic. So, from the Wikipedia article on I²C, we learned that this is a protocol or technology that has been developed by Philips Semiconductor, which today is known as NXP Semiconductors. And it's a fast serial interface that allows devices to be connected in a chain fashion, which means that I²C operates like a bus. I'll do a little drawing to explain what I mean by bus, just to make this a bit more clear. All right. So, imagine that this box here represents your Arduino. And on the long header, at the end of the long header, we've got these two pins, special pins called SCL and SDA. So there is SCL and there is SDA. Imagine now that you would like to connect a series of sensors to it, such as this one here, for example. This one is a gyroscope and 3-axis accelerometer, and it allows us to detect position and motion of travel, for example, for a quadcopter or some other kind of moving gadget. So we'd like to connect that to our Arduino so that we can get readings of the sensor. We'd also like to connect other devices such as perhaps a temperature and humidity sensor or a barometric sensor, which also implement the same type of communications interface. So what we can do then is we can have those devices nearby, and then using the same lines, I'm just going to draw two different wires coming from the SDA and SCL. There's one and there's two. Those can connect directly to our devices. The same wire can connect all three, or there could be more, of course. The limit is very high. It's about 127 if I remember correctly. Using the same two wires, we can connect all of our devices together to the master, the Arduino. So the Arduino here acts as a master, and the rest of the devices act as slaves. So there's one slave, another, and another, and so on. You can have many, many more. So this is what I²C or TWI looks like in practice. The implementation in terms of the software that we use inside our Arduino Sketch is fairly simple and high level, because the Arduino IDE, which is the environment that we use to program the Arduino, comes with a special library that makes the use of the I²C protocol very simple. And I'm going to show you that a bit later when we start talking about devices like this one here, like sensors that implement I²C. And there are many such devices in the Arduino world that implement I²C and make communications easy between themselves and the Arduino. As far as the purpose of the two wires are concerned, let's have a quick look at that as well. So the green line represents SCL, and the blue line represents SDA. Now, SCL, the CL part especially, stands for clock. Like everything else in a computer system, and of course the Arduino is a digital computer system, everything depends on a clock. And every time that the clock ticks, In the case of the Arduino, the clock is this silver device, which is a crystal that is ticking 16 million times every second. And every time the clock ticks, a new bit is sent over the blue line, because the blue line represents data. So data travels through the blue line, and every time that the clock ticks, a new bit is sent through the blue line. Another thing that you should remember is that every one of those devices needs to have a unique address in order for the master to be able to send data to a specific device. The master can send data, of course, to all of the devices at the same time, and that's called broadcast. But if you want the data to be sent specifically to one device or the other, then we use an addressing scheme and simply a number. So we call this device device number 1, and this device device number 2, and this device number 3, and so on. So these are unique addresses for each slave. I'll be showing you a more practical example as to how to use I²C TWI and how to connect a I²C device like the accelerometer and the gyroscope to your Arduino in a separate lecture. One last thing that I want to mention before I move on to SPI is how come this protocol has got 2 names. This is something that causes confusion. The reason that we've got 2 names is because, as I said earlier, Philips or NXP Semiconductors is the owner of this particular trademark. So I²C is a trademarked name that belongs to a particular company. Because other companies often do not either have their own implementation but do not want to get into any kind of legal trouble with NXP, they came up with a alternative name to basically describe the same protocol. TWI, which stands for 2-wire interface, since obviously this interface only has 2 wires. A last bit of interesting information in relation to the I²C interface is that on the Arduino Uno, you've got the SCL and ESDA clearly marked pins, but you can also get the same functionality from 2 of the pins on the analog input header. The SDA line is also implemented on pin A4, and the SCL line is also implemented on pin A5. So you could either use these 2 pins or A4 and A5 and you get the exact same functionality. It's still a single channel, so you don't get 2 channels for I²C. These 2 channels are connected together. A5 is SCL and A4 is SDA.